Hello everyone, let's discuss the phasor representations of transformer under load condition for different types of loads. So how many types of load we have? Resistive load, inductive load and capacitive load. So before the discussion of that, I would like to explain the equivalent circuit of transformer under load condition and no load condition. So first the equivalent circuit of transformer under no load condition we have to discuss. This is the primary coil. There is a magnetic coupling between primary and secondary. This is secondary. Now the operation is what? Under no load condition. So obviously I2 which is equals to 0, right? There is no load. Obviously I2 should be equals to 0. Then coming to so we have what? Resistive branch and reactive branch which are connected in series, right? Then we have a supply voltage of V1, and then because of this we have what? I0 only. This I0 can be, there is no current through this, there is no, because since secondary is what? Open circuited. Since secondary is open circuited, so I0 can be split into what? Full component and magnetizing component, right? So this is resistive branch R0, this is X0. So this is what? I0. Here this is equivalent circuit of transformer under no load condition. This is E1, this is E2, this is N1 and clear. So we all know that R0 should be equals to V1 by AW and X0 should be equals to what? V1 by I mu, and the magnitude of I mu is 3 to 4 times of IW. Therefore R0 should be more than I mu, right? See, IW is very less, therefore R0 is what? More than X0, and IW should be equals to what? I0 cos phi 0. I mu should be equals to what? I0 sin phi 0. Therefore I0 should be equals to what? IW square plus I magnetizing component of current whole square. Then coming to equivalent circuit of transformer under load condition. Primary winding and there is secondary winding, right? So we have a supply V1, like that we have a load across secondary, it is variable load, right? So what is the branch now? This is resistive branch and this is reactive branch. Then because of this V1 we have current I0. Now it is what? I0. This is what? I1 dash, right? Load component of primary current. I0 is what? No load current. I1 is what? Primary current. So this is E1 E2, N1, N2, and this is V2. That's it, right? So here I1 should be equals to what? I1 dash plus I0, and I0 should be equals to what? IW plus IM. This is what? IW. This is magnetizing component of current, right? Vector addition of these two. This is the equivalent circuit of approximate equivalent circuit. This is not exact equivalent circuit of practical transformer. This is equivalent circuit of transformer under load condition. So before the discussion of phasors, I would like to explain some important note points or observations. What is the power balance condition? Power balance condition. What is that power balance condition? We all know that phi 1 dash should be equals to phi 2. That is load component of primary flux should be equals to load component of secondary flux. So flux should be equals to what? Which is equals to N1 I1 dash should be equals to N2 I2. N1 I1 dash should be equals to N2 I2, which is equals to what? Load component of primary ampere turns should be equals to load component of secondary ampere turns, right? So from this we all know this V2 by E1 should be equals to N2 by N1 should be equals to, from this N2 by N1 is what? I1 dash by I2, right? Which is equals to K, which is equals to transformation ratio. Have you modified the terminologies in the earlier lecture? If you are not, just do the modifications. So K is nothing but transformation ratio. So from this I1 dash equals to what? K into I2, right? I1 dash equals to K into I2. Therefore K is what? E2 by E1. K equals to E2 by E1. From this I1 dash should be equals to E2 by E1 into I2. Therefore E1 I1 dash should be equals to E2 I2. Right? E1 I1 dash should be equals to E2 I2. This is volt ampere rating of a transformer, right? And one more important point, we know that these are very important observations. We know that I0 should be equals to vector addition of watt field component of current and magnetizing component of current. Like that I1 should be equals to I0 plus I1 dash, right? If no load current I0 is neglected, since it is having very less value, right? Because only 5% of full load current, that is 5% of full load current. That's why if it is neglected, what will happen? From 1 I1 should be equals to, sorry, this is I1 dash only, right? I1 should be equals to I1 dash. If I0 is neglected, I is equals to I1 equals to I1 dash only, right? So let us take, this is 1, this is 2, from 2 I1 dash equals to, then from 1 N1 I1 should be equals to N2 I2. Sorry, N1 I1 should be equals to, sorry from this one, this is 1, not this one. From 1 N1 I1 should be equals to N2 I2. From this K, which is equals to what? Approximately equals, right? I1 by I2. K equals to, we all know this, I1 by I2, right? So from this E1, or K is nothing but what? E2 by E1. Since I1 dash should be equals to K into I2. From this formula, this is the result. So K equals to I1 dash by I2, right? But from this I1 equals to I1 dash, therefore K equals to I1 by I2. Therefore we all know this, K equals to what? E2 by E1, which is equals to what? I1 by I2. So from this E1 I1, which is equals to E2 I2, approximately equals to E2 I2. This is what? So from this we can conclude that transformer is considered as constant power device. So if I0 is neglected, of course, what is the magnitude of I0? Only it is 5% of full load only. 5% of full load only. The remaining 94% or 95% of current is nothing but I1 dash only. There is no much change between I1 and I1 dash. Approximately these two are equal only. If it is neglected, obviously these two are exactly equal. If it is not neglected, approximately these two are equal. If I0 is not neglected, what will happen? I1 approximately equals to I1 dash. What is the reason? Since I0 is 5% of IFL, there is no much change of these two currents. That's why approximately the transformer is referred as constant power device. Okay, just remember this relation, I1 dash should be equals to K into I2. And what is the transformation ratio? E2 by E1 should be equals to N2 by N1, which is equals to I1 by I2. This is nothing but transformation ratio. What is trans ratio? E1 by E2, N1 by N2, or I2 by I1. That is trans ratio equals to what? E1 by E2, which is equals to N1 by N2, which is equals to I2 by I1. Just you have to remember the difference between these two, trans ratio and transformation ratio. Now we have to discuss the phasor representation of different types of load. Pure resistive load. The load is what? Pure resistive load. This is pure resistive load, right? Then what will happen? The secondary power factor is always, or secondary current is always depends upon the type of load, that is I2. I2 is always depends upon the type of load. Then how can we draw this phasor? Just listen. Always taken phi as reference. Main field flux is taken as reference. We all know that I mu is always in phase with flux, and which is lags the supply voltage by 90 degrees, right? By 90 degrees. But we all know that the operation of the transformer under no load condition is what? Is consisting of IW and I mu. IW is in phase with V1, I mu is in phase with phi, but I mu lags V1 by 90 degrees. What is the resultant between IW and I mu? The resultant between these two is nothing but this is I naught, right? Therefore, the angle between V1 and I naught is nothing but phi naught. This is the phase angle between no load phase angle phi naught. Clear? Then what about E1 and E2? So V2 should be equals to E2 because both are equal. This is E1. E1 and E2 are in phase. V1 should be equals to, we all know that, minus E1. Oppose the nature. Not oppose the nature, opposes the supply voltage. Clear? Then see the load. The load is pure resistive load. That is phi is equals to 0 degrees between, that is secondary current should be in phase with this terminal voltage I2. That is the point. So obviously let us take second. What is the relation? I naught should be equals to IW plus I mu, and I1 dash should be equals to K into I2. Therefore the magnitude of I1 dash should be more than I2. That is the point, because K is what? Transformation ratio. K is transformation ratio, and I2 should be like this. So obviously I2 is like this. So in order to draw I1 dash, it is I1 dash by K. Obviously it should be, let us take this is, which is more than this I2. This is I1 dash, right? Then we all know that I1 should be equals to what? I1 dash plus I naught. So in order to draw phasor diagram, you have to remember this current values. So I1 should be equals to vector addition of I1 dash plus I naught. So I1 dash is there, I naught is there. Then the vector addition between these two is nothing but I1. The vector addition between these two is nothing but I1. So like that you have to draw the phasor. So between V1 and I1, the phase angle is nothing but phi 1. Between V2 and I2, phi 2 is equals to 0 because load is pure resistive load. Therefore phi 2 is equals to 0. Phi 1 is some angle, phi naught is some angle. Clear? Like this you have to draw the phasor diagram with respect to pure resistive load. Next, coming to inductive load. Say coming to inductive load, this is V1 which is equals to minus E1. This is equals to what? V2 which is equals to E2. This is E1. Clear? Okay. Then this is what full component of current? This is I mu. I mu is somewhat more. So this is the resultant current I naught. So see the load. The load is inductive load. Obviously the current lags V2 by some angle. Current lags V2 by some angle. Therefore current lags V2 by what is that angle? Phi 2. Right? Obviously I2 should be equals to what? K I1 dash into K. Obviously the I1 dash should be like this. So we have I1 dash and I naught. The resultant between these two is nothing but what? This is I1. So between V1 and I1 is nothing but phi 1. Between V1 and I1 dash is nothing but phi 1 dash. Between V1 and I naught is nothing but phi naught. So like this you have to get different phase angles of V voltage and currents. Okay. Like that you have to draw phasor diagram of capacitive load. That is current leads this voltage by how many degrees? Phi 2. So obviously flux, this is the I mu and this is IW. So between I2 is like this, I2 leads voltage by phi 2. Obviously I1 should be drawn like this. The resultant between I1 dash and I0 should be equals to what? I1. So like that you have to draw the phasor diagram. And here I am going to explain some important observations. So for inductive load, what will happen? Listen these observations carefully. If phi 2 is decreases, if phi 2 is decreases, that is cos phi 2 is increases, right? The secondary power factor increases. What will happen to the primary power factor? If phi 2 decreases, that is cos phi 2 is increases, then what will happen to, if phi 2 decreases means what? Obviously that is if phi 2 decreases, phi 1 dash is also decreases. See, from this phasor diagram, if phi 2 decreases like this, obviously the phi 1 dash should be decreases, right? If phi 1 dash decreases, what will happen to phi 1? Phi 1 is also decreases. That is phi 1 is nothing but what? Primary phase angle. That is phi 1 dash is decreases, which means what? Cos phi 1 is increases. That is, what is the statement? If phi 2 is decreases, cos phi 2 is increases, then phi 1 is decreases and cos phi 2 is increases. This is very important observation. With respect to load, we have to wear the different, we have to get the different phase angles. So in case of lagging load, there is no reduction of phase displacement. There is no reduction of power factor. Always cos phi 2 is more. Sorry, cos phi 1, not phi 2. Just correct this. Cos phi 1. Simple. If phi 2 just you have to analyze from this phasor diagram. If phi 2 decreases, what will happen? This phi 1 dash should be decreases. If phi 1 dash decreases, what is the resultant between I1 dash and I1 should be decrease. Phi 1 is decreases. Phi 1 is decreases. If phi 1 is decreases, obviously cos phi 1 is increases. That is primary power factor is increases. Clear? So from this capacitive load, if phi 2 decreases, that is if phi 2 decreases, what will happen? Phi 1 dash increases. Phi 1 dash if phi 2 decreases, phi 1 dash decreases. If phi 1 dash decreases, what will happen? Phi 1 decreases and then increases. See, from this position to this position it is decreases, phi 1 decreases, but after reaching this axis it is gradually increases, right? From this position to this position, this phi 1 is decreases, but after reaching this axis the phi 1 angle should be increases, like this, increases. The phi 1 angle is increases. So phi 2 decreases, phi 1 dash decreases, phi 1 initially decreases, then again increases. Therefore cos phi 1 increases and then decreases. That is, what is the statement? Yes, we have to analyze by seeing this phasor diagram. If phi 2 is decreases, that is cos phi 2 is increases, then phi 1 is what? Decreases and then increases. Therefore cos phi 1 increases and decreases, increases then decreases. This is very important observation. Just go through this observation clearly. From this phasor diagram you have to analyze the different power factors of primary and secondary, whether the load is inductive or capacitive load. Just go through this important observations once again. Thank you.